Hi, welcome back. In this video, we're going to work through another exponential growth example. So in this example, we're given that a bacteria culture grows according to the law of natural growth, and the bacteria count was 400, that's 400 cells after 2 hours, and it was 25,600 cells after 6 hours. The first part of the example, part A, asks, what is the relative growth rate? So we know the growth rate is the first derivative. So if the population is P of t, population at time t, then the growth rate is dp dt. The relative growth rate is the growth rate relative to the population. So first of all, remember what the law of natural growth says. The law of natural growth says that the growth rate, dp dt, is equal to some constant times the population at time t. It's proportional to the population. So that means that the relative growth rate, the growth rate relative to the population, is dp dt over p, or k times p, divided by p. So the number we're looking for is k. The relative growth rate is just that constant of proportionality, k. So we're going to use the population after 2 hours, which is 400. We know that that means p of 2 is 400 cells. And we know that p of 6 is 25,600 cells. And also we know that the law of natural growth says the population at any time t has to be the initial population times e to the kt, where k is that relative growth rate that we're looking for. So using the two populations, 400 and 25,600, we can write the ratio p of 6 over p of 2 is going to be p of 0 times e to the k times 6 over p of 0 times e to the k times 2. Now the left side, 25,600 divided by 400, that's just 64. The right side, we can cancel the p of zeros, and we get e to the 6k divided by e to the 2k, which is just e to the 6k minus 2k, or e to the 4k. So remember, we're trying to solve for k. K is in the exponent, so the way we get it down out of the exponent is we take the natural log of both sides. So we've got the natural log of 64 is equal to 4k. So k is 1/4 times the natural log of 64. And if we rewrite 64 as 8 squared, we can simplify this a little bit. We can call it 1/2 times natural log of 8. All right, so that's the relative growth rate of this bacteria culture. Let's look at part B. Part B says, what was the initial size of the culture? So now we're looking for p of 0. We can use one of the populations that we were given, so let's use p of 2. P of t, we know, is p of 0 equals e to the kt, where k is 1/2 natural log of 8. So p of 2, which is 400, is p of 0 times e to the 1/2 natural log of 8 times 2. And we can simplify that exponent. So we have 400 is equal to p of 0 times e to the natural log of 8. E to the natural log of 8 is just 8. So it's 400 equals p of 0 times 8. And now we can solve for p of 0. So dividing both sides by 8, we get p of 0 is 50 cells. So we started with 50 cells. 2 hours later, we got 400. Okay. Part C says, put it all together and find an expression for the number of bacteria after t hours. So putting it all together, we get p of t is equal to p of 0, which is 50, times e to the k, which is 1/2 natural log of 8, times t. That's the population at any time t. And then finally, part D says, when will the population reach 50,000 cells? So remember, we started with 50 cells, and then 2 hours later we had 400, and then 4 hours after that we had 25,600 cells. So sometime after 6 hours, we're going to have 50,000 cells. Okay, let's figure out how long it really is going to take. So using the function we found in the last part, we set 50 e to the kt equal to 50,000 cells. And remember, k was that number 1/2 natural log of 8. So here we can divide both sides by 50. We get 1,000 is equal to e to the 1/2 natural log of 8 times t. And now taking the natural log of both sides, we get natural log of 1,000 is 1/2 natural log of 8 times t. Now we just divide both sides by 1/2 natural log of 8, and we get 2 times natural log of 1,000 over natural log of 8 is t. So putting it into a calculator, we get t is approximately 6.6 hours. So remember, after 6 hours, we had 25,600 cells. So a little bit more than a half an hour later, we had 50,000 cells. That's exponential growth. You can see how quickly things grow. All right, so that's exponential growth, and I'll see you in some other video.